Okay, this is the Grasshopper tutorial that follows the kind of general introduction and talks more specifically about the Canopy script that is being given to you to adjust for your studio project. The best thing to do is to start with a empty Rhino file. You can make sure that it's set up as feet. If you remember from some of the previous video tutorials, the units that Grasshopper uses are generic, and they are whatever the number of units or whatever the type of units are that are in Rhino. So for instance, if my base units in Rhino is set at feet, in Grasshopper, if I have something that is 8 units, it will be 8 feet. So contrary to when we're working in Rhino on a specific project, in this particular project for the Canopy Grasshopper script, it's going to be best to be working in your base units as feet. You can double check that if you already have a file open in your settings dialog box, or options dialog box, sorry. It's going to take a second to open here. And under units, you can check to make sure that your model units are as feet. Once you have that done, you want to open Grasshopper. Just type in Grasshopper into the command line, and as long as you have Grasshopper installed on your computer, it will open it automatically. I already have it open, I just have it minimized on my computer. And then you want to open File, Open Document, the Grasshopper script that Dan has provided for you. So again, I already have that open, so I'm going to pull it up over here on the right. Remember that on the right, in the top right corner, underneath your minimize, maximize, and close icons are all of the open scripts that you have. So this sawtooth roof script is what we're going to be working with. And let's take a look at what kind of has been given here, and then we'll look at what shows up into the Rhino file. So you can maximize the Grasshopper viewport by minimizing and maximizing the window, and then the kind of four-corner icon here allows for you to zoom to the entire document. So it'll zoom to the extents basically of the entire Grasshopper script. Typically we read scripts top left to bottom right, so top to bottom and then left to right. So let's look at what it's asking for, and then we'll move into the Rhino file. So it's asking you to set a grid in your Rhino file, or I'm sorry, in your project handout. You're being asked to create a series of stalls that cover up to 60. A series of bays that cover up to 60 stalls. So you're going to work through the dimensions of that and determine, is it 10 bays by 6? Is it 60 by 1? Is it 30 by 2? Whatever the proportion of your overall configuration is, you're going to determine what the dimensions of that are. So if it, say for instance, if I have, let's say I have a grid of 5 by 10 bays, and my bays are 10 by 20 feet. I know these aren't the specific numbers for your design, but these are just a hypothetical. I would have a grid that is 50 by 200 feet. And so I would determine which direction that's going in, so which way are the narrower stalls and which way are the wider stalls. And what the script is asking for you to do here are to create a series of 3 points that set an origin or a base point, and then a primary axis and a secondary axis. So if you have a rectangle, let's switch into Rhino really quickly. If I have a rectangle that represents a particular dimension, say 50 feet by 200 feet, I'm going to have a primary direction and a secondary direction. Ignore this. This is something that we'll get to in a minute. But you can imagine that this is the origin point, and this is a primary direction and a secondary direction, or this is a primary direction and a secondary direction. Determine whether you pick one point or the other first or second. So In the case of this particular script, it's telling you that it has a primary direction, secondary direction, and the secondary axis or the secondary direction is the one in which the sawtoothing is going to occur. So you want to make sure that you're setting the right axis as primary and secondary, otherwise your sawtooth is going to be going in the wrong direction. The grid dimensions are the number of units that you have in each direction, right? So your overall grid is going to be, say, 50 by 200 feet. How many divisions do you want to have within that? So you already figured out the dimensions based on a number of grids or number of stalls in each particular direction, but you need to go in and tell Grasshopper what those numbers are. So for instance, in my primary direction I might have 5, and so I could type that in here and hit OK, and in my secondary direction I might have 10, and I can type that in here and then hit OK. One thing to note, and we'll go back through this in more detail in a few minutes, is when you have a panel like this that's sending data into a component, or make sure that you don't have any extra spaces or returns. So don't accidentally hit enter and then hit OK, because it's going to read the information incorrectly. You want to make sure that all you have in this panel are the numbers with no extra spaces or returns. So once you set these, or that's the place where you can start to set these. The wave control is talking about the waviness of your roof in the secondary direction. So all of the bays in the primary direction are going to be the same, and then in the secondary direction they're going to start to follow this sine wave curve. And it's asking you where you want the wave to start. Do you want it to start at the beginning, or do you want it to start a few bays in? And how frequently do you want it to cycle through? So if I have 10 bays in one direction, do I want it to cycle through every 5 bays? Do I want it to cycle through every 10 bays? Do I want it to cycle through every 2 bays? You can start to think about that, and the nice thing about Grasshopper is that you can look at different options very quickly. So I could go in and look at 2 or 5 or 10, and once we go into the Rhino file, we'll take a little bit closer look at that. The height controls are talking about the minimum and maximum height of the canopy itself above the ground plane. So for example, in the handout for this project, at least the version that I have, it gives a minimum and maximum height of 12 and 18 feet. So the minimum height, or the beginning height of the canopy above the ground plane, is 12 feet, and the maximum height is 18. So I've gone in and set those as my parameters under this series of variables. And then finally, the overhang adjustment. So when our sawtooth happens, it's basically taking a rectangular grid and peeling one side of it, or a rectangular plane and peeling one side of it up, hinging it up, essentially. What this allows you to do, and it's an optional kind of variable, is slide the end of that panel forward or back, right? So if you slide it forward, it's going to hang over. If you slide it back, it's going to create a kind of a pitched panel within that bay. And again, we'll take a look at that when we move into the Rhino file in a second. Basically, these other sections in the middle you don't really have to worry about. There's a description here that describes what's happening within these components. So these things are clustered together, and together they create a rectangular grid from the variables provided in the grid controls, which are over here on the left. The wave function allows for the kind of pulling of the different heights along the curve and lifting up the edges of the panels to meet those heights. And then the move component moves each grid intersection point along the z-axis by a value determined by the wave function and adds the overhang adjustment. Basically, it applies that to the overall grid. And then lastly, the resulting geometry comes over here and ends up as these extrudes on the far right. So you can see that the darker gray components are not previewed. So we talked about that in previous tutorials. They have been grayed out, meaning that they're not showing these stages of the design development process. You can go through at any time and preview these, but because this is intended as kind of a black box definition, I wouldn't really make any major adjustments to the center section. I'd really be working specifically over here on the left with the grid controls or the grid components, and then over here on the right with the resulting geometries that you're going to bake into the Rhino file. So again, you work left to right in Grasshopper typically, and what you end up with on the right are the things that you're going to want to bake into the Rhino file. So in this case, the things that you'll eventually want to bake are the extrudes and the vertical lines that are resulting here. So let's look at what all of this means in Rhino. I'm going to get rid of this rectangle. It was the one I was using as an example for a 50 by 200 grid. So you can see the geometries are being previewed already here based on the information that I've already put into the file. Let's look and see what happens when we start to go through these step by step and determine what's happening. The grid start point, we talked about this earlier, is asking for an origin point and then primary and secondary axes. So what I've done in Rhino is draw a point, and you can just use that. You can do that using the point command, and I placed it anywhere. You can start it anywhere. And then I found the easiest way, or I think the easiest way to create the other 2 points is to have your ortho snap on and just copy this, right? And so depending on what your overall dimensions are that you're using for your kind of area that you're working within, you can copy it from one point to another. Say I want it to be 100 feet. I can type in 100, hit enter, and click, and let it know I want it in that direction. And then the same thing is true in the other direction. So let's say in this case I want it to be 60 units wide. So I'm going to enter 60 with ortho on, snap it over into the other direction, and click to set that as the ratio. Then I can go through with each of those points, and let's say that this is going to be my origin point. So I'm just going to, this is going to look a little bit weird for a minute as it's resetting all of the points. So I'm just going to turn this off for a second. And I'm going to get rid of these other points just so it's not confusing. So these are my 3 points. Origin, this is going to be my primary axis, and this is going to be my secondary axis because I want it to be curving or adjusting in this long direction. So right click on the origin component, the point origin component, and set one point. I'm going to go in and click on my point. It's letting me click on it because I have O snaps on, object snaps on, and I also have the point as one that is activated. So the point in the primary axis, I'm going to right click on that one. Again, this is the direction opposite or perpendicular to the direction that you want the variability to take place. So again, I'm going to click on this point, and then lastly, the secondary axis, right click, set one point, and I'm going to set this as my point. If I turn the preview geometry back on again for Grasshopper, you can see that now my grid structure that is being automatically generated by Grasshopper is mapped to those points. The grid dimensions are currently showing you in the primary axis, which we set as this direction. It's giving you 5 bays, so 1, 2, 3, 4, 5. And in the secondary axis, it's giving you 10 bays. So if we went through and counted this, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? If you double-click on the panel, it's going to bring up the editing component, and you can adjust this to whatever you want. Again, remember no spaces or returns. Hit OK, and you can see that the bays are now going to adjust to 4 by 10. The wave controls, these are a little bit trickier to see, so what I'm going to do is exaggerate the height of things so you can see it a little bit more clearly. So I'm going to change this to 24. You will be working with Dan to start to look at, to answer any of the questions that you might have about what you can modify beyond the project handout, if anything. So we can see now a little bit more clearly, and I'm going to go into the left hand, or the front, I'm sorry, the front view in my case. Set view front, just so I can see in a elevation view what the resulting canopy structure is looking like in elevation, or it also could represent section. So if I start my wave from 0 and have it have a frequency every 5 units, if I start to change that, you should start to see some change occurring within within the overall. I'm going to get rid of this for a second, this overhang, so it's not confusing. We'll come back to this in a minute. Right, so it's looking at a start point and a frequency and a minimum and maximum height. So this would be 12 above. I think I want to change this to an odd number. I'm wondering where my variability is going here. Maybe I need it to be a higher number. I'm not getting any sort of differentiation, which I was having no problem with earlier, of course. Well, I'm going to go back in then and adjust the heights, so 12 to 18. Maybe this is affecting something that we're not anticipating. Okay, so you can start to see it here. There must be something in the definition that's kind of mapped to something that we're not seeing. So you can start to see that the wave start and wave frequency is creating different combinations of waviness for the roof. And they are waving within this 12 to 18, or they should be waving within this 12 to 18 foot variable. And so if we were to bake this into Rhino at the moment, we could measure this. It would be 12 feet, and this would be another 6 feet up. And remember that your base units in Rhino need to be in feet so that these units start to map to those. If not, if for some reason you were working in inches, you would enter a dimension here that was whatever the height in feet that you wanted it to be was by multiplied by 12. The overhang adjustment, as it says here, edits the field to change the overhang amount to the sawtooth. So this is the sawtooth, right? So it's pitching up on one side, and then at the moment it's going straight down. If I were to change that to 2, for example, you're going to see that it's shifting out over the vertical line of the column grid 2 feet. And so again, in our side view, front view, you can start to see what that looks like, right? You can measure this. Our grid is based on feet, so you could measure this over 2 units, etc., etc. You can also set this as a negative dimension, so if I wanted to set it as -6 and hit enter, it's going to shift that point back 6 feet in this case, and so it's taking what would be here and either shifting it out or back. This allows for you to, the reason that the negative is interesting is that it allows for you this potential to have kind of a ridge in between each of the column grids, each of the column bays. Again, don't worry about these, don't worry about the wave function or the grid move at this point. What you do want to end up with, and the things that you do want to be able to look at the end of the day, are the extrudes, which are these surfaces, as well as the vertical posts that are representing the columns. And so these are in at the moment and are going to allow for you to very quickly and easily create all of these elements in Rhino and then utilize them to make them three-dimensional for your model. So as you know, what you would do at the end of the day when you're set with your design after you've finished adjusting things is take the components that you want to create in Rhino or to bake into Rhino, right-click on them, click Bake, and you would likely have your file set up so that it had essentially a columns layer and a panels layer as the start from Grasshopper, and hit OK. And then those lines are now in Rhino, and you can start to edit them or use the pipe command, P-I-P-E command, to create a dimension around them, and I'll show you that in a second. And then lastly, the extrude, right-click and bake, and I'm going to put that on a different layer, hit OK, and now I have those in my file as well. You could go through if you wanted to, and if you didn't want your panels or your overall structure to be basically extruded in this direction, you could create a series of these. Definitions and adjust the different components in between each of them. So, for example, I could take all of this and copy it, Command C, Command V, sorry, Control C, Control V, and move it. And let's say my point here is going to be moved from here. And I'm just using these the vertical elements because they're already in place. And so my Grasshopper script is updating. It's going to look the same in here because my Rhino file is, or because my Grasshopper definition has been baked into Rhino, but I can go in and set the primary axis. I can reset it. So set 1 point. I'm going to set it here now. Oops, sorry, my mouse just jumped. Set, right click, set 1 point. Here. And so you can see that the Grasshopper definition is moving, and in this version I would want it to be 1 bay, so it's 1 bay at a time. And then in my second version down here, I would set a different origin and primary axis. So here I would click on this, right click, set 1 point, and it's going to be this point. So I'm starting it where the previous bay ended, and then I'm going to set the primary axis, set 1 point, as the next column line over. And I would have to do this as many different times as there were bays that I wanted to control individually. Again, I would make it 1 unit in that direction, or 1 bay in that direction. And if I were to Control A and hide all of the geometry that had been baked, you can see that I can start to control the second version of it. I can start to control the second bay differently. So if I type in 3 here and hit OK, these are going to start changing, right? If I were to say that this guy had 0 overhang, I could start to look at the composition and see what results. So you can see the difference between these. In this case, I might go up into the first grouping, right? So up here, and say that my bay in this direction is 20 feet. So I might say that this is -20. And it's really just about understanding what the geometries are. Oops, sorry, actually -10 in this direction. I don't remember my own units that I used. Basically, the control that you have over this is the more control that you can have over this is based in the number of, or based in the geometry and your understanding of it and your control over it. This is not a very nice composition in terms of the roof structure because I haven't really been considering how it works. But you're going to be designing things much more consciously than I am. I'm just trying to show you the different versions or the different abilities to control what results here. Again, at the end of the day, you would need to bake the lines and the planes, in this case now in both sets of kind of parameters. And you would bake those into Rhino, again remembering that you would want them to be organized by layer. So that's more or less how the kind of given Grasshopper definition works. you're going to be working with Dan in Studio to kind of control these variables and use this as a design tool in your process. I did want to show you one quick thing in Rhino that will help you with some of this, is your lines once you bake them into Rhino. Put them on layer 4 this time. And I'm going to unpreview my grasshopper geometry. Remember that happens up here, so I want it to not be previewed. So I'm just looking at the lines at this point. You can use a command called pipe, P-I-P-E, to give these what are now just non-dimensional lines a certain thickness. So pipe is the command. I'm going to create a pipe around this curve. The start radius, I believe you're given particular dimensions, so let's say the radius is going to be 3. Actually, we want that to be, let's see, we'll say in this case 0.125, so 1/8 of a foot, which is a strange dimension, and the same thing at the base. And I'm just hitting enter to allow for those to be entered into Rhino, and it will create basically a tube around it. You can do multiple at one time. So if I were to select all of these pipes, or all of these lines that I want to make pipes around, except for the previous one, I'm going to hit enter. The radius is fine. We'll leave it at, let's say 0.25, which is 3 inches, which is exactly what we want. And it's going to create a 6-inch diameter or 3-inch radius pipe around each of these lines. So I think that that's a pretty quick and easy way to get a round dimension, kind of 3-dimensional shape in there. If you did want to create a square tube or a square column, you could do that either by making a square. Right? So you could use the rectangle command and start at the center. And so the center of the rectangle is going to be the end of the line. And then the dimensions are going to be 6 by 6. Oops, sorry, again, I am forgetting that this is in feet because I typically work in inches. So the center, and then 0.5 and 0.5. That shape can then be extruded along the curve, so you could take this and either sweep one rail or extrude curve. So this is the curve that you're going to extrude. Right click or enter to select that, and then you can use the end point of the line as the extrusion dimension, so then you could get a rectangular column instead of a round one. So as I mentioned in my email, please feel free to send me questions that you might have with this. I think Dan's going to be the one who's addressing more of the design-related questions, but if you have any technical questions, feel free to contact me. I am out of town. I won't have access to all of my software equipment, but I can email you back or speak to you on the phone and talk you through most of the issues that you might be having. So have fun.